Yeah, so part of the review that I've been leaving you every day was to revisit the CASP website, right? All right, very good. So today I want to cover some of these problems just so that we do a quick review and we see a couple of things that maybe you have doubts on. But here's the process again. I'm going to zoom out. All right. So once you go to CASP.org, from there you go to Practice and Training Test. You go to Student Interface and Practice and Training Test. From there you sign in. Select your grade level, which is 8th grade. Press yes. For the next sections, you don't need to write any information. All you need to do is select the Start Grade 8 Math Practice Test. Scroll all the way down, select. Scroll all the way down, yes, start my test, and begin test now. And that would send you to this page. So we're going to go over these really quick. So on your paper, write number 1. And I want you to draw the number line. Draw the number line. That's why you have a ruler, right? Okay. So I'm going to zoom in, and this one says drag each number to its correct position on the number line. So on the number line, I want you to label it 0, then dash, 1 dash. Then the next dash is going to be 0.1. Let me zoom in so you guys can see it. 0, bless you, then a dash, then 0.1, dash 0.2, dash 0.3, and so on and so forth, all the way to 0.8. Okay? Now, to get started, we're going to look at this one right here. Square root of 4 over 5. So let's see. Square root of 4. What is square root of 4, guys? What number times itself gives us 4? 2. So this becomes 2 over 5. Now, 2 over 5, we can make it into a decimal. Is that correct? Yeah. Bless you. So then we do 2 divided by 5. 5 does not fit into 2, so that's 0. 5 fits into 24 times, and we're done. And where's that located? 0.4. So right here, when you know what the value of that fraction is in decimals, so that means you're going to drag it. Check this out. So basically just grab it and place it where it belongs. Then let's go to the next one. Pi over 5. Let's see. Pi over 5. First of all, the value of pi, remember when we covered the circles? It was 3.14. Is that correct? And that's over 5. So that means 3.14 divided by 5. Does 5 fit into 3? No. Into 31, 6. That's 30. Subtract. And I see some of you are not writing. Then you bring down the 1 and the 4. Does 5 fit into 14? That's twice. That's 10. Subtract. That's 4. Add another 0. And it fits in there 8 times. And we're done. So 6.28, if we round that to the nearest hundredth, this becomes what? 0.63. 63, right? So 6.3, here's 0.6, here's 0.65, so 6.3 is about right here, is that correct? Yeah. So let's do that one. So I'm going to get this. It's not here because that's half, a little bit less, which is about right there. Are we there so far? Yeah? So let's do the last one. And the last one, which is 3 over 10, which means 3 divided by 10. Does that fit in there? Nope. So how many times does that fit in there? 3. So that's 30. Subtract. So this is 0.3 or 0.30. And you obviously see it there. So then the last one is probably the easiest one. Grab that, place it there. Once you're ready, so then just move on and boom. Over there? All right, did you place it on your number line where each one went? All right, good. Let's go to number 2. For number 2, just write, we're going to start with this one. It says, for each number, indicate whether it's a rational or irrational. So I want you to make a little table, copy this table, which means you're going to draw 1, 2 lines down, 1 across. On the first column, you write 4 sevens, then square root of 30, 21 over square root of 4, pi, and negative 27. Everybody there? All right. So, a rational is any number that can be expressed as a fraction. An irrational is a number that we cannot take the square root of, which means it's a decimal that does not end, and it keeps repeating, but it doesn't keep repeating. It does not end, the sequence never ends. So, for example, let's go with the first one. 4 sevenths. Let's see. 4 sevenths, can it be written in a fraction form? It's already a fraction. That means it's a what? Rational. Look at the second one. Can we take the square root of 30 without getting into decimals? Let's see, what is square root of? No, there is no square root of 30. So that means that's an irrational. Let's look at this one. 21. What is square root of 4? 2. So that becomes 21 divided by 2. Is it a fraction? Yes. And do we have any decimals in the denominator? No. So this is a rational. Now let me show you one that is not before we move on to the other. If this was 21 over square root of 5, even though it's a fraction, can we take the square root of 5? No. Therefore, that would be a what? Irrational. Does that make sense? Look at the last one. The next one. Pi. 3.14. Does it ever end? No. Pi never ends. It keeps going. And actually, so that you guys remember, there's an actual supercomputer out there that scientists have going already for years. And the decimal, it's still going for pi. It hasn't stopped. And that's been already that was back in, I think, 96, 20 years already. And it's still going. And it still hasn't stopped. So if it's still going and it hasn't stopped, that means that we cannot really make a fraction out of it. Then this is a irrational. Irrational. And look at the last one, negative 27. Can we make negative 27 into a fraction? How do we write it? Over 1. Therefore, this is a rational. That make sense? All right. Let's go to the next one. And you guys are writing this down, yes? Very good. So, rational, irrational, rational, irrational, rational. Okay, it says a square side length S. So write for number 3, and I want you to write this equation. S squared equals 324. So, they're saying A square side length S has an area of 324 centimeters. This equation shows the area of the square. There's the equation. What is the side length of the square in centimeters? So what they're saying is this. There's a square. The area is 324 squared centimeters. I'm going to put that here, squared centimeters. So that means this side, if it's a square, it has to measure the same as this side, right? So what number times itself gives us 324? So when we are given this equation, S squared equals 324. You guys wrote that down, right? Write the line down, the equal sign. To cancel this squared, we need to take the square root. So whatever we do to one side, we do to the other. So we're left with S equals, and let's find out. Let's see. 12 times 12 is 144. Give me a big number that comes close to once we multiply it. 15 times 15. Let's try. 15 times 15. 20. It ends in 5, so does this one end in 5? No. What other one do you want to try? 20 times 20, it ends in 0. Does that end in 0? And by the way, this is 400, so we already went past. So it's not 15. What other? 18. Let's see. Let's try 18 times 18. 8 times 8, that's 64. Uh-oh, yeah, so far so good. Got 6. That's 14. 8, 1. See, 4, 2, 3. Yep, bam. So the side length here, when they give you this problem, you need to type in 18. So let's see if it allows me to do that. Yep, that's it. And notice that they don't give you so you can write centimeters. So you just write the number. That's all they give us. Move on. Okay, this one. Number 4. Write this down. Write this number down. 7.5 times 10 to the 5th. Everybody wrote that down? Okay, that's scientific notation. You guys remember that? Yeah. All right, so it says, approximately 7.5 times 10 to the 5th gallons of water flow over a waterfall each second. So how many? In each second, 1 second, right? There are 8.6 times 10 to the 4th seconds in 1 day. Select the approximate number of gallons of water that flow over the waterfall in 1 day. So let me ask you this. This is for 1 second. Yes? And this other number is for the entire day. What are we need to do to those two numbers in order to find out how much water for the entire day? Multiply. So write this one down, please. So, read me the first number, Johnny. What was it? 7.5 times 10 to the 5th. You put that in parentheses. Open another parentheses, and we're going to write the second one. 8.6 times 10 to the 4th. So, let's see if we remember. Since it's multiplication, look for the ones that have the same base. Which ones have the same base? The 10 and the 10. So these two, they keep the same base. And we're multiplying. What happens to the exponents? Who remembers? You add them. So put a little plus sign on top so you remember to add the exponents. That becomes 10 to the 9th. All right, so we're done with that. Times, I'm going to put a big dot for the multiplication because it's indicating it with a parenthesis, right? Now we need a number here by multiplying what? 7.5 and 8.6. So I'm going to do that over here. 7.5 times 8.6. We're going to multiply. And I'll give you some time to do that. I'll give you a head start. Go. Okay, here goes the multiplication. See if you got it right. I'm going to start with 6. 6 times 5. 30, I got 3. 6 times 7, that's 42, plus 3, that's 45. Next, 8 times 5, that's 40. I got 4. 8 times 7, that's 56, plus 4, that's 60. So therefore, I bring 0 down, 5, 4, and 6. How many decimal places? 1 and 1, that's 2. So it's 64.50. Hands if you got that. Yes. However, look up, please. Look up. However, in this, they're asking to see which one of these is a solution. So watch. Notice that none of them have 64. They all have 6.4. You guys see that? So this is where you need to be and say, well, this is not scientific notation. Do you guys remember that? Because we need to move the decimal one more time. If we move it 1 to the left, 1, you need to add 1 to here. So this is 6.450 times 10 to the 10. Make a little note for yourself to remember that when you get to scientific notation. So let's look at the possible answers. 6.45, all of them, and the 1 to the 10th is C. But let's look at the possible answers of these. Look at 10 to the 21st, 10 to the 20th. What do you think they did with the 5 and the 4? They multiplied. So be careful with those mistakes. Here they multiplied. Here, after they multiplied, they moved the decimal over and they added 1 more. Does everybody see that? What was the mistake here? They didn't add 1. They just moved the decimal. Does that make sense? So just be careful with those. So I'm going to select this one and move on. All right. Look at this one. With your ruler, just copy this graph. Let me zoom in. There it is. It goes up to 100, so I'm going to, okay, let me zoom out a little bit. So copy this one. The x-axis is in time in minutes. The y-axis says distance from Jason's house in meters. Copy that. So if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8 tallies for the x-axis. And the y-axis goes by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So these are meters, and this is time in minutes. So let's go through this graph together. So this line, they drew a line from 0 straight to right here, and this point is what? 250. So draw a line segment up to right there. Everybody there? So let's see. It says the school is 100 meters from Jason's house. So we have to finish somewhere up here. The following describe his recent trip. He walked 50 meters towards school in 2 minutes. So 2 minutes, 50 meters. So there's his walk, his progress. Are we there? But then it says, he realized that he left a book at home. He turned around and walked home at the same speed. So think about it. Talk it over to your neighbor. Let them know what else are you going to draw after that. Tell your neighbor, please. So right now we are here. What are you going to draw after that if he returned home at the same speed? So let's see. Help me out with this one. Emily G. Do I continue going up? I go down. Why don't we go up, by the way, everyone? Because he's walking back, and he's going to be at 0 distance again because he's going to be at home. And how many minutes did he make it home? 2. So that means we need to draw. Guys, focus, please. We need to draw a line from here to there. Hands if you did that. Yes? Because we were at 50, and in 2 more minutes, he got home. So he's at 4. Everybody see that? All right, so now we are at 0 meters again, but now how much time has passed already since he left the first time? 4 minutes. So then it says, he spent 1 minute looking for his book. So from here, what do I do if he spent 1 minute? Move to the right, go to 5, right? So we are at 5. Then it says, he walked all the way to school at twice his original speed. So think about this one. His speed earlier was every 2 minutes he did 50 meters. Every 2 minutes, 50 meters. If he walked twice as fast, tell your neighbor what you should do. Tell your neighbor what you should do. So who can help me? In 50 meters, how long did it take him to cover 50 meters if he walked twice as fast? 1 minute. So at 6, he should be at 50. Is that correct? Yeah, because it cuts his time in half. So in 2 minutes, he should be at where? 100. So therefore, that's his progress. Everybody see that? Okay. So be careful with these word problems because they're going to give you some of those also. So make sure you focus on the trajectory as you go along. Okay? So let me draw those lines so I can move forward. Let's see. Connect. Bam. Is that a 7? Yeah, right? 6, 7, and 100, right? Because it was twice the speed. Let me go to the next one. All right, look at this one. This is going to be the tricky one. So for this one, send a gopher to come get a graph paper for you.
I got you. Just 1 or 2?
1. And for those of you that are not going to get enough, just draw your coordinate plane like so. I'm going to zoom into the graph so that you guys can copy this copy the points first before you connect the segments. All right. So on your graph paper, use a large graph paper. Here it goes. The first point. Look up, please. The first point is, let's see, at 2, and I'm going from left to right. At 2, 3. Does everybody see that? So plot your point at 2, 3. The next point is at 3, 0. The next one is at, I'm going to start from the bottom to the top. I'm at 4, negative 1, put 1 right there. At 4, 1, put 1 right there. At 4, 3, put 1 right there. And at 4, 5, put 1 right there. Ever see that? So once again, 4, negative 1, 4, 1, 4, 3, and 4, 5. The next one is at 5, 4. There it is. And the last one is at 6, 1. So now with your ruler, 6, 1. Now with your ruler, draw this figure on your graph. And I suggest you start with the very first point we started with, which is this one. Draw a line straight to this one, 4, 1. Then from there, go to 3, 0. From there, go to 4, -1. From there, go to 6, 1. From there, go to 4, 3. From there, go to 5, 4. And then at the end, 4, 5. Okay? Everybody there? All right. Now let me zoom out really quick. It says, use the connect line tool to draw the image of the figure after the following transformations. Look what it says. A reflection over the x-axis. Here it goes again. A reflection over the x-axis. Okay, so check this out. Look what I'm going to do. Reflection over the x-axis. So I'm going to zoom in, and then I'm going to show you exactly what they're talking about. A reflection means that they're using the x-axis as a mirror. So watch. I'm going to zoom out a little bit. Okay, there it is. Okay, look up, please. So which is my mirror? The x-axis, right? So this line right here is a mirror. So imagine this is looking at itself in a mirror right here. So let me ask you this. How many steps is this point away from the x-axis? 1, 2, 3. That means if it's reflecting on the x-axis, a point is going to be reflected 1, 2, 3 points this way. So plot it there. You see what we're doing? All right. The next point, 3, 0. Does that one's right on the line, so do I do anything with it? No, it stays on the line. So I just go over it one more time. There it is. These next ones are going to be the tricky ones. Here we go. Look up. I'm going to start with this one on top. This one is how many steps away from the line of the x-axis? 1, 2, 3, 4, 5. So I'm going to go 5 this way. 1, 2, 3, 4, 5. How many steps is this one away from the line, from the x-axis? This one right here. 3, and we're still on x value of 4, right? So 3, 1, 2, 3. How about this one? How many steps is it away from the line? 1, and we place 1 there. And look at this one, though, because look, we haven't checked this one. How many steps is this one away from the line? 1, but on the other side, right? So that means I'm going to need to highlight this one also. I know, right? So, with that said, let's go to this one right here. How many steps is this one away? 4, and that's on the 5. So 1, 2, 3, 4. And how much is this one away? 1, which is right there. All right. So once again, let's start with this point. This one went, let's see, it connected to this one over here. And this one is above the 4, right? Which one is above the 4 right here? That one, right? So that means I'm going and I'm going to do this. Get your ruler, do that. From there, it went to the 3, so I'm going to go to the 3. From there, it went over the x-axis to this one, so I'm going to go over the x-axis to that one. From here, watch, I'm going to follow this one. I'm going from down here to this one over here, which is on 6, right? Which one is on 6? This one, so I'm going to go from here to there. From 6, I'm going to go to this point right here, which is at 4, 3. Do we have one at 4, -3? Yeah, which is right there. So I'm going to go like that. From there, this one goes to 5, 4. Is there one at 5, -4? Yes, I'm going to go like this. Do you guys see the ending here? Like this and like that. See what we did? We reflected it off the x-axis. It is hard. That's why you guys need to really think about the steps away from the x-axis. But are we done? Let's see. No, it's saying watch. Step 1, reflect over the x-axis. Step 2, a horizontal translation. Horizontal is like this. 7 units to the what? So from where it's at now, it has to go how many to the left? 7. So watch. Let's do this together. I'm going to use green. Look at this point. I need to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. There it is. Look at this point right here. It's at 3. I need to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. Look at this point below the 4. I need to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. So I'm here. Look at this point right here. This one is at 2, negative 3. That goes 7 to the left. 1, 2, 3, 4, 5, 6, 7. This one right here. Hold on. I got this one. I go to this one. 4, negative 3, 7 to the left. 1, 2, 3, 4, 5, 6, 7. This one, 7 to the left. 1, 2, 3, 4, 5, 6, 7. This one, 1, 2, 3, 4, 5, 6, 7. And this one, 1, 2, 3, 4, 5, 6, 7. And we just reflected and moved it 7 units to the left. That's pretty cool, right? Once again, revisit that website, please, over the weekend. Get some rest. Get a good snack to eat before you come to school on Monday. See you guys till Monday. Enjoy your home play. Bye. Bye.